So what we do at Granite Key, is we have a tool called Granite View, and one of the things that we do is we do threat modeling. And I'm not going to get into a lot of detail here, but if you see, one of the technologies has an X in it, meaning that we're not going to deploy, for example, a hardware security chip. And if you go to the very top, the firmware provisioning is yellow, meaning that if you don't have a place to store the keys, if you're just going to store it in a locked room, you're going to be vulnerable. And what you can do in a threat modeling tool is you can drill right up to the management level and say, if I add a security chip right there, if I take the X out and add a chip, look at those two things there, the X and the yellow. If I take the X away, the yellow turns green at the firmware provisioning level, at the highest level. The idea there is you could take something that's very complicated and explain it to management that your return on investment of deploying a security technology is positive. And that is the biggest message you can give to management. And so you need a tool where you can get down into the details, but it rolls right up to the management level, really where the key challenge in security is. So the idea is you have a collaborative visual representation of threats. You can make choices. You can make technology choices. Yes, it's true that this technology costs more money, but if you look at it from an ROI perspective, scenario A, where you use a secure E squared, has a negative ROI. Scenario B, where you use, say, a board ID chip, has a positive ROI. These are the kind of things that you need to do to sell security at the management level. You can do scenarios around trade-offs of different costs at the system level as well. We can put a secure boot or not put a secure boot. What's the probability of failure? It's really a statistical and financial decision. And you could also build a security roadmap. Maybe today we're not going to put secure boot in, but as we increase our volume, and maybe it costs 1 penny or 10 cents to put a secure boot in, but when we get to a certain volume, the CFO knows that it makes sense to spend money on secure boot. So our view of sales, again, ROI. I'm going to summarize this in sort of a chart which reminds me of economics, or microeconomics. I think it was macroeconomics. Let's say, going back here, this is the chart we had earlier, where if you want a higher level of security, it's going to cost you more money. And the benefit of security is going to tail off. What's going to happen is at some point, it doesn't make any sense to spend more money on security. So if you subtract benefit minus cost, you get a curve, an S-shaped curve. If you spend a little bit of money on security, it's a waste of time because it's not secure enough to make any difference. If you spend too much money on security, it's also a waste of money and a waste of time. And so, for example, in the left side of this curve here, you have a false sense of security. Is that if your objective is compliance, then you can be on the left side of the equation. But if your objective, if you have a business case where you've been hacked, you want to be on the right side of the equation. You want to have a positive ROI. So for example, secure E squared is generally on the left side of the equation, whereas something like a board ID chip or a smart card is generally on the right side of the equation. So now we're going to move to a couple of quick use cases to illustrate how some of these security chips are integrated into products. And we're just really going to focus on one use case. And it's the one where we have to authenticate a peripheral. So for example, we work with customers where they have peripherals that are disposable. They can only be used several times, and a significant share of their revenue model is this peripheral. We call it the razor blade model. And the idea here is that how can we put a chip onto the peripheral to protect that peripheral? The chip becomes the identity of the peripheral. So we can take, for example, a Renesas board ID chip, and we can put one of these chips onto both peripheral, and we can use asymmetrical encryption and all the things that we learned before. And then what we're going to do is when the main unit is turned on, it's going to send a challenge to the chip on the peripheral, and the chip on the peripheral is going to respond. And one thing we can do is we can actually put a timer or a counter on the peripheral to only allow it to respond with an authentic response 10 times or for 10 hours. And then once the response is authenticated, the system becomes fully operational. And the idea there is that putting the security chip in there is the easy part of the equation. The more difficult part is understanding how are we going to do the enforcement. Again, back to the plastic bag. But the key thing here is to put a security technology in there that cannot be hacked within a reasonable level of cost. And so again, it's a financial decision. But the challenge here is to really understand at a holistic level where you're going to deploy your technology and how you're going to secure it. If the peripheral was expired, for example, if we put a counter inside the peripheral, which is very common to enforce single use or limited use, this is very common in medical devices, is that again, we're going to have two security chips, board ID chips in the units. The board ID chip inside the peripheral is going to have a record of its usage. It's going to have a counter in it. When you send it a challenge, what's going to happen is it's going to respond that it's expired. And the main unit will not operate if it gets an expired chip. And again, if we go back to our previous case, you can enforce that in firmware, you can add a hardware chip, you can have secure boot in there. It all depends on what level of security you need for this application. So moving on to the summary. So in summary, what are some of the best practices in security? As I mentioned before, secrets are stored in devices with physical protection. Murphy's Law. Don't put the key on top of the doormat. Don't put the key under the doormat. Don't put it in the mailbox. Put it inside a chip. Use standard security algorithms. Use public key technology when available. And the reason there, again, is to try to prevent the use of a master key. Even if you store a master key inside a FIPS-level device, a physically secure device, there's always a slight chance that that master key is going to get out. And so, again, you apply Murphy's Law and use asymmetrical keys whenever possible. Use recommended key lengths from NIST. NIST on their website has a list of the algorithms and the recommended key lengths. It's all public information. And again, use system security. Focus on the plastic bag and the processes. Don't get caught up in the security technologies. If you want to know what security technologies to use, go to NIST website in terms of the algorithms, and then use hardware-based chips if you're going to protect symmetrical and private keys. And remember also that you have to understand your provisioning process. We didn't go over this a lot in detail, but when you issue keys to devices, they are directly responsible for your revenue stream. And in many cases, every key you issued is worth money. So it's just like a bank. And so you're no longer just issuing VPN tokens, you're issuing something that goes right to the bottom line. The CEO wants to know how many keys have been issued. Lifecycle management. Focus on ROI. Security is about return on investment. All technology ultimately is about a return on investment. It's about customer features, customer experience, and financial returns. It's not about the technology. It's very important to remember that. I cannot emphasize that enough. Start early in the life cycle. Security, like quality, should be designed in from the very beginning. It reminds me of the quality initiatives of the 80s. Really focus on the quality or the security mindset. If you really have a dedication to security, if you're really focused on a positive ROI, you have to think that way. And your organization has to think that way. Use ROI-based threat modeling. It's very common for us to work with customers and say, wow, this security technology or this component we have to put in costs money, but let's take a look at the financial returns of it. Yes, it's going to increase our unit cost by 5 cents, but it's going to reduce the probability of failure by X. This goes right to the CFO. CFOs understand this kind of thing. The idea here is to have clear information and don't allow the complexity of the technology to obfuscate the key issues, which is what are the scenarios we're choosing, what are the financial differences between the scenarios. And finally, I want to just review very quickly Renesas security product lines that relate to security. One is the board ID chip, has the highest security protection. It's very similar to a smart card. You can get a FIPS level certification. Renesas also has an AE series, which are smart cards. Same level of security as board ID chips, but they have ISO 7816 interfaces, which means they're smart cards. They can run with Java card, and they're used in a lot of traditional systems that are already out on the market. Renesas also has secure microcontrollers that can be embedded inside a circuit board, and they don't have a FIPS level of security, but they have a logical level of security, and sometimes that's adequate. Again, especially if you're using public key cryptography. And then the N-series chips, again, a lower cost security, not as much security, but again, if your system is less expensive, if you're protecting a low cost device, you have low volumes, you might have a positive ROI putting in a lower cost security solution. Here are some references that you can look at. I'm not going to go over them. You can look at them on the presentation and get some good web information about security. And then finally, here is our contact information. Again, I'm Mark Schaefer at Granite Key, and here are my contacts over at Renesas. You can also go to Renesas' website to get information about the board ID chip. And I want to thank you all for the presentation. And remember that security is all about quality. It's about really understanding ROI. It's a business decision. And like everything else, it's really a mindset. And you can really enjoy the process of taking the desire to have quality, to have integrity, to have security, and bring it at a holistic level. Really take that level of integrity and bring it into your engineering, bring it into your management, and create a very secure system. That's what we do, and I'm very pleased to share that information with you. Thank you.